Hello again. So, one thing that was a consequence from the last problem is that the diagonals of a rectangle are equal to each other, obviously, and equal to the square root of the sums of the squares of the length and the width of the rectangle. So it's just a consequence of Pythagorean theorem. You really don't need to memorize this, but if you understand how this formula works, it can just save you some time in finding the length of a diagonal. Anyway, let's move on to the next problem. Prove that the quadrilateral formed by connecting the midpoints of the sides of a rhombus is a rectangle. So, I think a good way to do this problem is to go and use GeoGebra, because it's a very excellent tool for like quickly finding like midpoints and stuff and like that. So the midpoints of this rhombus. Now we have to keep in mind some of the facts we know about rhombi. The most essential one is that all the side lengths are the same, and that they are parallelograms, which means that the opposite angles are the same as well. And we also have to keep in mind that the diagonals of a parallelogram bisect each other, so the same is true of a rhombi. So let's connect the diagonals with each other, and we are going to say that they meet at this point here. Well, actually no, we don't need to do that because we're just trying to connect the midpoints. So all these basic facts we know about. Let's then find the midpoints of the sides. So we have midpoint here, midpoint here, midpoint there, midpoint here. Now we want to connect the midpoints together. So E, F, G, H. Now it looks like a rectangle. Now we just have to prove that it is. So how can we go about doing that? Well, we can understand that since all the sides are the same, and we have that E, H, G, and F are splitting up their respective sides, so all of these lengths have to be the same as well. Now, what do we have left with? Well, we notice all these triangles we have formed on the edges, AHE, CEF, DFG, and BGH. They are all isosceles triangles. So, what do we know about isosceles triangles? Well, we know their base angles are the same. Now, for example, A and C have different angles, but regardless, the base angles, the base angle here, let's say it has a measure of x. That means the same measure is over here. But since the angle at C is different from the measure A, well, we know the base angles are the same, but it's just going to be a different value. So we're going to call that y instead. Now, angle D is the same as angle A, and since it's isosceles, that means these two angles have to be x as well. The same measure as the isosceles triangle at AEH. Likewise, since the angle at B is the same as the one at C, we have that this is angle Y. So, where does that get us? Well, the definition of a rectangle is that all of the interior angles are the same. So I want to find out what this interior angle is here. And I know it has to be 90 since it's a rectangle, but I don't need to show that it's 90. I just need to show that they're all the same. So how can I show that all of these angles here are exactly the same? Well, if we notice the angle X and our mystery angle, like let's call this one Z. And then we have Y. Well, X plus Z plus Y has to be 180. Why? Because they're on a straight line. So X plus Y plus Z equals 180. And assuming we have some X and some Y, Z has to be the same number. There's no two different numbers that when added with X and Y is going to get you 180. So that means looking at the other corners, we have the same dilemma. We have Y plus X. That means the middle angle has to be Z to get the 180. And we have the same pattern for all the angles. So since we have shown that the interior angles of EFGH are congruent. So, by definition, EFGH is a rectangle. So that completes our proof. If we connect the midpoints of this rhombi, there's, no matter what the measures of the angles or the sides are, we are always left with, by connecting the midpoints, those interior angles always have to be the same. And since the interior angles are all the same, it has to be a rectangle, because a rectangle is a quadrilateral where all the interior angles are the same.